Welcome back to exam review for Algebra 1B, page 4. Objective, we are solving equations. Again, we are trying to find a number or numbers that, when placed in for x, would make the equation true. So 5x minus 9 equals 26. This is Algebra 1A or prior to that type stuff, but important nonetheless. So we are going to add 9 to both sides. And we're going to see that 5x is equal to 35. And we're going to divide by 5 on both sides to get x by itself. And we're going to see that x is equal to 7. And that is our answer for number 22. For 23, we're going to have to follow our orders of operation here. So we have to distribute our 9. So we're going to get 9x minus 18 plus 5 is equal to 7x plus 3. Now again, we need to get our x by itself, so I'm going to combine like terms here, and we're going to have 9x minus 13 equals 7x plus 3. We're going to add 13 to both sides, and that's going to get rid of our 13, and then we're going to subtract 7x from both sides, and that's going to remove our 7x from the right hand side. So notice how that's going to cancel out that, and that is going to cancel out that. So 9x minus 7x is 2x, and 3 plus 13 is equal to 3 plus 13 is equal to 16. We're going to divide by 2, and we see that x is equal to 8. Number 24, we have an absolute value sign. So what values can I put in for x that I can take the absolute value of that would equal 5? Well, the answer is both a negative 5, x is equal to a negative 5, and x is equal to 5. For 25, what we're going to do is we're going to get the absolute value of x plus 1 all by itself on the left-hand side. In order to do that, we are going to add 3 to both sides. So then we are left with 2 times the absolute value of x plus 1. These 3's cancel out, then 5 plus 3 is equal to 8. Now, right now, you can kind of picture the absolute value sign as parentheses, so we can just divide by 2 on both sides, and that's going to cancel that out. So we have the absolute value of x plus 1 is equal to 4. So here's where we get two answers, because as we've seen in 24, both negative 5 and 5 both work. So we're going to have another two different numbers that will work for this x. So we make two little mini equations. We say that x plus 1 is equal to 4. And we also say that x plus 1 is equal to a negative 4. So basically what we do is we just drop the absolute value signs. We set it equal to what we see. And then we do the same thing over here, but we set it equal to a negative of what that is. And then here we just simply solve for x. So we subtract 1 on both sides. And we're going to say that x is equal to 3. And here we're going to subtract 1 on both sides. And we'll see that x is equal to a negative 5. Now, if you're unsure of your work, again, feel free to take that number and plug it back in for x, like I'll do right now. So if I take a negative 5 and I plug it in for x, a negative 5 plus 1 is a negative 4. And as I take the absolute value of negative 4, that turns into a positive 4, which means that a positive 4 times 2 is 8, minus 3 is equal to 5. So the negative 5 definitely works. And for fun, let's put the 3 back in for x. 3 plus 1 is 4. The absolute value of 4 is still equal to 4. Times it by 2 is going to be 8. Minus 3 is 5. So we are good on both of those. So for 26, we have an absolute value with an inequality. It says that the absolute value of x minus 3 is greater than or equal to 9. So it's kind of like what we just did on 25. We're going to make two little mini problems here. We have the absolute value of something all by itself, so we don't have to do anything before we start this. and we're going to say x minus 3 is greater than or equal to 9, and we're going to make a equation that's x minus 3 is less than or equal to a negative 9. Now notice how on the second one, I flipped my inequality around and I made this number negative. So then we just solve for x on both sides by adding 3. It's going to cancel that out. So x is greater than or equal to 12, 9 plus 3. And then x is less than or equal to a negative 9 plus 3 is a negative 6. So here we make a filled in circle. We put a negative 6. And because it is less than, we draw our arrow to the less than part. And then we make another filled in dot. We call that 12. And we draw an arrow going greater than because x is greater than 12. Now remember, we put the filled in dot when we have the equals to. That means that 12 is included in our answer and negative 6 is included in our answer. So looking at 27, we have x, the absolute value of x is less than 3. So we say, do the same thing. X is less than 3. And then for our second equation, we flip around our inequality and we put a negative 3. So now we put a circle at negative 3. Notice how I made an open circle because there's no equal to sign, so that is not part of my solution. And we draw it to the right. And for this, x is less than 3. We have our open circle at 3. And we draw our arrow to the left. And these two arrows meet, so our solutions to this equation is everything that's within here. Number 28, we have 7x squared plus 4x minus 3 is equal to 0. Now, this is our quadratic function here. So we can go about this a couple different ways. One is using our quadratic formula. Which, just a reminder, is a negative b plus or minus square root of b squared minus 4ac. And this is all over 2a. So in this equation, the important part is to have your function or your equation equal to 0, and a is equal to 7. Your a is always what's in front of your x squared. Your b is equal to 4. B is always what's in front of your x, and c is equal to negative 3. Your c is what does not have a x associated with it. Now again, if you do not have a b or a c, that is perfectly normal. If they would just be equal to 0 at that point. All right, so a negative b would be a negative 4, and we're going to say plus or minus the square root of b squared, which is 4 squared, and that is 16, minus 4 times 7 times the negative 3. So 4, I'm going to do that in my calculator so I don't make a mistake. 4 times 7 times a negative 3 is a negative 84. So I am subtracting a negative 84, and this is all over 2 times a, which is 2 times 7, which is 14. So as I break this down, I have a negative 4 divided by 14 plus or minus the square root of a negative 16 minus a negative 84 is 100 over 14. So the square root of 100 is 10. 10 times 10 is 100. So I have a negative 4 plus 10, which is going to be 6 over 14. And then a negative 4 minus 10, which is going to be a negative 14 over 14, which equals 1. That cancels out to equal 1. So my final answer is x is equal to 6 over 14, and x is equal to 1. Again, if you want to take the time, go ahead and put 6 over 14 in for x and put 1 in for x. And I just almost made a mistake as I was checking myself mentally. A negative 14 divided by 14 is a negative 1. Okay? It's always a good idea to check your work. So number 29, we have 3x squared. And what we're going to do is we're going to subtract 17 from both sides. Equals 48. Then we're going to divide by 3. We have x squared is equal to 16. Now what we can do here is we can take the square root of both sides. But the trick is when we take the square root, x is equal to plus 4 and minus 4. Because when we square a negative 4, we get 16, and when we square a positive 4, we get 16. So we need to account for both of those answers. Now that was solving a little bit differently. Another way you can solve this would be the quadratic formula, where you need to put, I'll start all over, 3x squared plus 17 equals 65. Now what we have to do is we have to get 0 on the one side, so we're going to subtract 65 from both sides. We're going to have 3x squared minus 48 is equal to 0. So then we would have a is equal to 3, b is equal to 0, and c is equal to a negative 48. And from that point, you can plug everything into your quadratic formula, and you will come up with 4 and negative 4. Number 30, we have 3x squared minus 2x minus 15. I'll solve this one using the quadratic formula. So a will be equal to 3, b is equal to a negative 2, c is equal to a negative 15. Again, I'll write my quadratic formula up top just in case you forgot it. So now I start off with 2 plus or minus, because I have a negative 2, but as I put that in for negative b, that becomes positive. Plus or minus the square root of b squared, which is 2 times 2, which is 4, minus 4 times 3, which is 12 times 15, which is minus a negative 180, all over 6. So we have 2 over 6 plus the square root of 184 over 6, and we have 2 over 6 minus the square root of 184 over 6. So the square root of 184 is 13.56, and we're going to divide that by 6. And we're going to add 2 divided by 6 to that. If you're watching this video, hopefully you're working this out the best way that you know how. So, and then just check your answer with mine. That's the only thing I can suggest, because what I type into my calculator is what works best for me. You might find something that you understand something a little bit different on how to input that. But as long as you're getting the same answer, that's what matters. And so this is going to be 2.59. And down here we're going to have a negative 1.92. So there's both of our answers for x on that one. Number 31, we're going to solve a lot like we did 29. We're just going to add 25 to both sides. And we're going to see that x squared is equal to 25. Again, we'll take the square root, both sides. We're going to see that x is equal to plus or minus 5. Because, again, you can put a negative 5 in for x squared, and it's going to be equal to 25. So that's our answer. X is equal to 5, and x is equal to a negative 5. Again, if you want to use the quadratic formula still, for whatever reason, we're going to say that a is equal to 1, b is equal to 0, and c is equal to a negative 25. Number 32, we have x squared. I'm going to get 24 over to the left-hand side, so we're going to subtract 24 from both sides. X squared minus 5x minus 24 is equal to 0. Now, if we were using the quadratic formula, we would say that a is equal to 1, b is equal to a negative 5, c is equal to a negative 24. Now I'm going to show you another way to solve for your x or your x-intercepts, and that is by factoring. Remember that when we factor, we put up that big x. In the bottom, we're going to put a negative 24. In the top, we're going to put a negative 5. So now we need to figure out what multiplies together to get a negative 24 that will add together to get a negative 5. And the answer to that is 3 and negative 8. So as we write that, we say x plus 3 times x minus 8 is equal to 0. And what we do here, we know that one of these or both of them has to somehow become 0, because when they're multiplied together, we end up with 0. So what we're going to do is we're going to take each one. We're going to say x plus 3 equals 0, and we're going to say x minus 8 equals 0. So what we're going to do is we're going to solve for x. We're going to subtract 3 from both sides. And here we're going to have x is equal to a negative 3. And here we're going to add 8 to both sides. And we have x is equal to 8. Now again, if you want to take the time, go ahead and put these numbers into your quadratic formula. And you will get negative 3 and 8. So for 33, we're going to solve it the same way we did on 32. But again, I'll write down your a, b, and c for anybody that would like to use the quadratic formula. A is equal to 1. B is equal to a negative 8. C is equal to a negative 20. Don't get confused by the notation. Just pretend that instead of a y there, you have a 0 there. So you solve it just like we've been solving the last couple of problems. So we're going to say 0 is equal to, I'm going to make my x right here. I'm going to put negative 20 in the bottom and negative 8 in the top. And I see that 2 and negative 10 multiply together to get 20. They add together to get negative 8. So I'm going to bring this down a little bit more so I have some room. So I have x plus 2. And I have x minus 10. Again, I set each one of these equal to 0. X plus 2 equals 0. And x minus 10 equals 0. And I end up with x equals a negative 2 and x equals 10. Again, we just had to add 10 to both sides. And here we subtract 2 from both sides. And those are your x-intercepts. One good way to check this one would be go ahead and throw that in your graphing calculator. And your graph should cross the x-axis at a -2 and 10. All right, number 34 states, an arc of water sprayed from a lawn sprinkler can be modeled by the graph of the equation y is equal to a -0.05x squared plus 9x, where x is the distance in feet from the sprinkler and y is the height in feet of the arc. How far from the sprinkler does the water hit the ground? So please try to hold your laughter with my drawing skills, but we'll just call this our sprinkler. And here's our green grass. And as it shoots out, right, and it's going to hit our grass. So what it's looking for is how far does it land away, and this right here is our h. This is how high the water goes. Okay, so that's what our function is modeling, is this curve right here. Okay, so we know that when the sprinkler hits, the water hits the ground, it's going to hit the ground in 2 spots. One is right where it starts, the other one is over here on the other side. So what does y equal when the water hits the ground? Y is equal to 0. Okay, so let's figure out what our x is when the water hits the ground. So we say 0 is equal to a -0.05 x squared plus 0.9x. We're going to solve this using the quadratic equation, which again I'll write down again. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to see that a is equal to a -0.05, b is equal to 0.9, c, we do not have a c, so that is equal to 0. So let's plug everything in. We have a -0.9 plus or minus the square root of 0.9 squared minus 4 times a times c. Well, we're multiplying by 0, so we know that's going to be 0. All over 2a, which is going to be a -0.1. 0.05, a -0.05 times 2 is a -0.1. So here we have a -0.9 over 0.10 plus, now the square root of 0.9 squared is just 0.9. Basically, when we square something and we take the square root of it, we just end up right where we started. And we're going to divide that by a -0.1. And we're going to take a -0.9 divided by, excuse me, this is going to be a -0.1 as well. Divided by a -0.1, we're going to subtract 0.9 divided by a -0.1. So as you do the math here, you're going to see that a -0.9 divided by a -0.1 is just going to end up being 9. And then that's going to be plus a -9. So we're just subtracting 9, and that's going to be 0. And that makes sense, right? Because our sprinkler started at the ground. So when our height is 0, our x value is going to be 0. But we're really looking for this x value right here. We already know that the water is at the ground when it's at the sprinkler head. So this is going to be a -0.9 divided by a -0.1, which is, again, 9. And we're going to be minusing a -9, and that is going to be equal to 18. So the sprinkler is going to shoot the water out and it's going to hit the ground again after it flies through the air 18 feet. Number 35. A landscaper is building a rectangular brick patio and the area of the patio is A is equal to 5x squared plus 20x, where x is the width of the border around the patio. So if we draw a patio real quick, and we're saying that x right here is our width. The landscaper has enough money in his budget to purchase patio bricks to cover 105 square feet. With this budget, what can be the width of the border? So what we're doing is we're going to put in A is equal to 105. So we say 105 is equal to 5x squared plus 20x. Now the first thing I'm seeing is that everything here has a 5 in it. So I'm going to divide by 5 just so I can get simpler numbers. So 105 divided by 5 is 21 is equal to 5 divided by 5 is just going to be x squared. 20x divided by 5 is going to be 4x. Okay. And again, we can set that equal to 0 by subtracting 21 on both sides. So 0 is equal to x squared plus 4x minus 21. Now, we just solved using the quadratic formula. And again, if you want to use the quadratic formula, go ahead. A is going to be equal to 1. B is going to be equal to 4. C is going to be equal to a negative 21. But here we can solve this by factoring. We say 0 is equal to, we'll put our x right here. And this will be a negative 21. It'll be 4 up here. And that's going to be positive 7 and negative 3. So 7 times negative 3 is a negative 21. 7 minus 3 is 4. So we have x minus 3. And we have x plus 7. Again, we set both those equal to 0. Bring it over here, we'll say x minus 3 is equal to 0. So add x. X plus 7 equals 0. So our x's are going to end up being equal to 3 and x is equal to a negative 7. So we're asking for the width of the border. Now, our width cannot be negative. You cannot have a negative length for a border. So that is out of the question, and the width of our border will be 3. And that is it for solving functions.